Okay, everybody. The second talk of this session is from Tom from JP Morgan, and he's going to be talking about something that I know very little about. So let's just welcome him.
Good afternoon, guys. So I'm going to be talking about something that I don't think many people have necessarily come across in Python, and this is I guess it's not a new language, but it's an extension to the Python grammar that allows you to easily define user interfaces. That's the whole idea. So just a quick run through of what I want to do today. So I'm going to go through a little bit about what Enaml is. Attempt and hopefully succeed at some live coding and a little builder tool that we've got, and follow that up with a little tour of some features I won't touch on, but would feel like we should probably just mention them on the way, and some of the things that we've been adding lately, and some of the things that are planned to be added to the language in the coming months. And then hopefully we should have some time for some questions towards the end. So, as I said, what is Enaml? It's an extension to Python. Gives you a new keyword, which we'll see in a few minutes. A little bit like class, but instead the keyword is enamel-def. And from that place in the code, you can then define the tree of widgets you want to show on screen. So the easiest explanation I usually go with is it's a bit like the tree that you get out of HTML, or the tree that you get in other UI declarative type languages like QML and XAML, where you're always looking to try and get that kind of like window, and in my window I have some fields, and in my fields I define these attributes. That type of field is what you're going for. What we want to do is do that in a way that feels very Pythonic and that feels kind of at home in Python. So, it really aims to make it a lot easier to put together a UI. We don't really like using the PyQt or WX bindings because they're large, they're gnarly, you've got to know all of the options and toggles just to get them right. We want an environment where we can put a UI together very quickly, and not one where we necessarily have absolutely every option, but one that's quite terse and easy to use. So the difference you end up with is very much you have that type of code. This is also sort of pseudo on the left anyway. It's not a real library. That's just a way of ported over kind of what Enaml looks like to a version of code that has the same objects and things. In fact, I'd say it looks worse on the left-hand side. If you were to see this in PyQt or see this in WX, it would be more complicated than this example. But the right-hand side shows you something of what Enaml looks like. It's this tree with a root of enamel-def, and hopefully it's actually quite readable without me explaining much about what's there, right? We're going to end up with two labels, some fields you can type into, and I'm going to type this more or less out in a second, and a big button at the bottom that says button. So let's see if we can make that happen. So this is the builder, and we'll make things a lot bigger. There we go. Now, this is not going to be massive on this side, but hopefully people can see. So in here, in this little live coder, I can just go and do a lot of what we saw in the little example before. So I can do that, and it's going to end up with test on the side. So let's just build out that example we saw a second ago. So we can put a label in place. We can pop a field. Helps if I do the right syntax. I can pop a field in there, and I can put some text or something in the field, or I can pop a placeholder in. It's laying them out for us, but in a pretty naive way at the moment, just widget after widget after widget. But we'll see as we go along. I can do another one. If I can type, there we go. And finally, we'll do the last one and cheat slightly. So we get the basics. We can fire that form type piece around it. We'll end up with a nice looking form, similar to how we did before. We can knock a bit of the padding out, make it a little bit tighter. And as before, we can stick a button on the bottom, right? Oh, push button, sorry. We end up with an empty button, stick some text on it. I think it just said the button, right? So you can see you end up with the UI very quickly, right? Not a lot of code there, and you know, now we're in a place where we could start to change the layout, add things, change, continue on putting things in group boxes, whatever we wanted to dream up in our UI. But we've been able to do that in like less than a minute, sort of type it out and it's done. So I'll jump back just the slides. We'll just go through a few bits more. So proof that it can be a full complex UI. This is taken from a system we have in JP Morgan. It's a huge Python platform, like 30 million lines of code, hundreds of developers. In fact, in London alone, we have, I think probably getting on 300 Python developers there. And they make use of Enaml day in, day out to build UIs like these with full styling, constraints, and binding all of that back into our financial models. So it really can be more than the trivial example I wrote in the GUI builder. So the next big part of Enaml is that needs to be talked about is how it achieves some model view separation. So we just defined a view, which would have been a bit useless for most applications. Nobody really wants just two text boxes to type into. We want to bind the thing up, and we don't really want to end up with too much controller glue. For those of you you've done MVC type projects before, or maybe iOS is a great example of where the controller just gets quite out of hand. You want the data binding to just sort of happen, if at all possible, and where you don't want it to be just a two-way binding, a direct thing. You want some control, but you don't want to have to write reams of code to get there. So Enaml bakes that idea in and encourages you to go down a route of having a model object, and you'll see in the builder in a minute, and to also have your view defined declaratively and a model object that you bind the two things to. There's a particular library called Atom, which was sort of brought up alongside Enaml, but not exclusively for use in the UI, and we use it in other places as well, which we have a native binding for in Enaml. It's not the only binding that's there. You can, if you have an observable like object, you can do the binding for it, but this one comes out the box. So just to kind of make clear what this is before I go into the builder, Atom objects are like Python objects, but they a little bit like slots, so you can define, and you have to define all of your members up front, and it saves a little bit on memory and the like there as well. It has a relatively compact storage for your Py objects. You also optionally get some typing and defaulting and a few extra goodies, but crucially you get change notifications when things happen on the model object itself. This is not revolutionary, but it's very handy to have when you're trying to build UIs, and it makes this example work. So we take this example and carry on a bit further. Say we want to take a couple of names from somebody. So we'll go with first name and last name. And now, whereas earlier I wasn't caring about this little panel at the bottom here, this time I'm going to make my person object. So this one is my model. I'm going to have first name is a string, and I could put a default on here as well, like my own name. And I'm also going to have last name as well, so it'll tally up with what I've got in my view. Now the builder has a little bit of a convention going on, which allows it to wire up the model and the view for me, sort of top and bottom. And so this model object here, this attribute that I've defined at the top, will get glued to an instance of the atom at the bottom. You'd normally do that in code, in like Bootstrap code, when you start up your view or whatever. But in this particular in the builder, it does it all for us. So this is where data binding starts to come into play. So instead of having a placeholder value on here, I can go in and I can say text. And rather than just saying equals, which is just going to set the value, like you would expect, I'm going to do colon equals, kind of a bit like a becomes, or it's the two-way binding operator for Enaml, but you can kind of think of it like that. And then I'm going to go model.firstname. And I'm going to do the same for the last name as well, as you'd expect. You can already see actually there on the right-hand side, it's bound my last name to my first name. There we go. So now we have a view model separation already, right? The view is bound up, and when I change any of the values here, although there's no real interaction at this point, the value's changed on the model for me. And so we can take advantage of that in other parts of the UI. So we can go and say, let's have a label at the top, and let's do something a bit more complex. So this is where we meet the next and probably the other most powerful operator in Enaml. It lets you do a complex expression on the right-hand side and bind that into in this case, into the text member of label. So I can say something like, my name is, and I can just do a bit of normal. This is straight Python at this point, right? We're not doing anything particularly crazy. I can say model.firstName, if I can type, and model.lastName. Just move that over a bit. And this binds up, right? So now whenever I change this piece on here, I'm going to have a live update all the way around to the other view. Hopefully you can see how powerful this is, right? I really haven't had to do a lot of work to glue the view and the model together exactly as I want to present to the users. And my model has stayed very pure. I can test that very easily in unit tests. I can interact with it. I can add methods on it to do various things. And all of the changes that are happening in the model are going to get reflected straight back up onto the UI for me. So we can do a bit of that now. Let's add a button like clear. And we add ourselves a method like clear on the other side. And we can do just something super simple like first name equals blank. And now we meet the third and, well, not final, but the last operator of great interest. This allows me to take something here and run a block of code when an event occurs. And you can actually bind that to any of these. You can bind them to text and things as well. All these operators work across the board on all of the members. So that would be run this code when the text changes in some way. What I'm saying instead down here is run this piece of code when somebody clicks, when the clicked event fires. So then it becomes as simple as saying model.clear. That gets me what I want. Now I can do my name and things like this into this one. Hit clear, I get exactly the interaction I want. So you can start to hopefully see as you build all these things up, you can end up with a very succinct way of describing your UI. And all of this is nice, it's Pythonic, you can strict superset, so you can go and just define whatever you like at the top of here, right? No, you can do pure, just normal Python elsewhere in the module. Just to carry on a little bit further with the example, so the layout isn't ideal, and I think we probably want to put another button on here maybe to do something else. So let's say we have a button on here to do save as well, and we call a save method something relatively simple as well. We won't do a lot of saving in the model, but you can hopefully fill in the gaps. If you were to go and do this for real, it could go to a database, it could do whatever it wants. Although we'll come to it a little bit later, these interactions are happening on the UI thread, and so you don't want to block the UI for very long. If anyone's done much JavaScript or UI programming, they at this point know that you're on a queue and you don't want to block that queue at any point because you're going to freeze up your UI. So we've got some solutions for that, which I'll describe later. Other than having another thread and just handling all of the thing yourself, which is not always very much fun. So we get a bit of what we want now. We have a save method, and it doesn't do a lot. It probably prints off into my shell over here. Let's just sort the layout out slightly. So I won't go into vast amounts of detail as to how the layout constraints work today, because I could go on forever. But suffice to say, it's quite simple to add in some constraints around how we want Enaml to lay this whole thing out, right? Again, if anybody's been in this space before with say, well, just laying things out with CSS isn't great fun, but also in the likes of Interface Builder in iOS or in the .NET type builder tooling in Visual Studio, you kind of you end up fighting with it a lot to get what you want, right? This is designed to be simpler and it has well, I think anyway, it has a nice, easy and elegant way of getting what you want out of it, especially when you're using it like this in the builder. So if I just replicate roughly what was the default, so F save clear, right? This is not going to make any great difference other than now we have some explicitly defined constraints. Save and clear, I want them side by side. So I can stick those like this, stick a horizontal box around them. Still not quite right. I've ended up with a very big clear button and a very small save button, which is probably not what I was looking for. So, and this is the kind of thing that you end up fighting with all the time in these frameworks. Now, this is nice and simple. So I just need to say exactly what I want to say out loud. I want the save button to be the same. It's gone off the screen. I want the save button to be the same width as the clear button, right? So save equals clear dot width. And I get exactly what I want, thankfully. And this is all if I can get the handle on the corner, because all resizes properly and does exactly what you expect. So that's probably end of all things demoing. And it's exactly like I planned, which is really good. I'll jump back onto the slides and just go through a little bit about what else is there for us in Enaml. So that was a bit of a whistle-stop tour. There are some other things. So I mentioned briefly then and did a little example of the constraints. There's a lot of other things you can do. There's some helpers for doing grids. There's an option to have it so that you can call back and do all wondrous things with your constraints. But you're in a linear equation solving type environment. So you are still declaratively saying, I want these constraints to be held true and letting the engine go about solving those. If anybody's used Cocoa Auto Layout, that's the same sort of thing. They power it from Interface Builder, but it's the same tool and same engine behind it, basically, the same algorithm, same paper. Cascading style sheets. So they're not cascading style sheets like but they have a very similar feel. You define them in Enaml, and you can style widgets. Like you can just say all of the labels should be red, or you can say all the labels with the style class, whatever, need to be red, and the widgets can choose when they want those styles. And that's how we can achieve all the styling we see on the likes of this ticket, right? It'll all change dynamically depending on whether you're buying and selling and various other stuff. So it's a very much a bound up piece of styling, and it's part of the way Enaml works. Dynamism, there's a lot of cases where you want different views to appear at different times. You want to say, when I'm in this state, show these things, when I'm in this state, show those, or you want to go and look up what's the best thing to show for the user or what their preferences are, all these types of things. That's easy to do in Enaml. You can use two constructs that are available, includes and conditionals, to change the shape of that tree at runtime in response to your model. There's also some templating support, which I won't go into great detail with, but allows you to more easily have like a situation where you want things to be able to be plugged in and kind of like, it's not quite generics, but it's that sort of zone. It's also worth knowing, if it wasn't kind of obvious, that you can define attributes on your widgets, like I did at a model, and that was to give myself some storage space on the tree for holding on to my model reference. You can do that as many times as you like, and you can type them as well to give yourself a little bit more safety. You can also subclass the widgets, and that's how we can compose our UIs very easily. The example that we've got here, it's subclassing container. The person form is a container. But you can continue to do that. I could pull the form out from the bottom here and make it a special form that's always reused for models that have first names and last names and so on. So you can kind of get a feel for how you would reuse a lot of code. And the final thing to point out as well is you saw in the example there was a docking framework. I didn't show it off very much, but it is quite complete. You can tear widgets out, you can save things in their layouts. It's quite a rich framework, and that comes out of the box as part of the standard library. So a few things that are new that we've been adding gradually as we've been going along. So there's some syntax that's been added in to allow models to delay their value being there. We often come across a case where our model is a bit more complex than something we can just show straight up on the screen, and we want our users to get the view as quick as possible, and then as values come in from various sources, calculations happen, that type of thing, we can show them appearing. So the first thing that we added in that respect was delayed bindings. It lets you specify what you would like Enaml to do in the case where the value isn't ready, or the expression. It could be a long, complex expression. In this example, I've just done a value, right? But it could have been a list comprehension that was then sorted, and then I returned the first value from. If anything in there was not ready, then the expression's just paused, and when it later comes back and informs us that we're ready, we rerun the expression and bind. So this is an extension, so you can say this thing's currently loading or whatever. And the field also gets knowledge of how of whether any of its bindings are currently delayed. So it can gray itself out. It can do that type of behavior that you would expect, or you can put a spinner on the side if you've got time to write the spinner. It's all that sort of stuff. The other feature we have added is tracing. So there was already some tracing happening. In fact, that example I had with the little the string formatting, that was looking at the Python bytecode that was there, and it was pulling out all of the times I was reading parts of the model. So it then knew if first name changed or if last name changed, it needed to rerun the expression. That's only a one-liner thing normally in Enaml, and sometimes there are cases where you want that to be a whole, not a massive function, I hope, but a small function that's just going to do something a bit more complex than one line of code. So there's a decorator there now to make that easy. And also another feature of the way it works is Qt in the background. For those of you who were wondering, we haven't written all of the bindings for Mac OS and Linux and Windows. We've just leveraged PyQt. But because of that separation, we can just ask Enaml to not use Qt and to just use a different binding. And that's really handy when you want to run up your code. Like, there's no denying that there are pieces of code in your Enaml in Python, right? And that's kind of the point. But those pieces of code, they really need to execute them. We want to test that they're in a good state. When the model changes, we do want to check that those things have got into the right place. And that's independent of whether Qt is going to render them or not at all, right? So we have a fake kind of backend for Enaml, which you can use to run up the whole application, to be honest, and prod it, and then end up in a good place for your tests. So some things that are going to happen in the future, one particular feature I wanted to point out, and this is what I was talking about earlier, about blocking things on the UI. Right now, well, you're probably already aware of async support, async await in Python 3. Enaml is currently Python 2.7. Although the pull request for Python 3 will likely be merged in the coming weeks, so it's not really a support problem. But for those of us who are using 2.7, and that happens to be JP Morgan and happens to be the platform that we're building a lot of this code in, we were planning on adding some yield support into the language, which lets you it's coroutines basically. We'll have a scheduler, there already is one, that lets you do deferred calls and a queue and everything else because this is a UI. And it's going to just let the code make use of that and say, do this thing in the model, and just like async, come back and return the value when you're ready and finish running this block of code when the model's finished doing its thing, right? At which point you can pop up a message box like here and say done. That's something we're going to get added in the next, well, the plan is for the next month or two. It's not top of the list, but it's close. And that helps to alleviate those issues around, I have this operation I want to do, it's long running, but I don't want to block my UI, or it's a call out to a server, a HTTP call or something like that. You don't want to have all the I/O in your way, and you can instead use this to facilitate that type of interaction. As I said briefly, Qt 5, Python 3 are coming soon. And that's everything I have. So I hope a few people have some questions. Fire away.
Great. So if anyone has any questions, if you could queue up by the microphone. Not all at once. So my immediate question is if you've had any particular feedback or problems or challenges with Enaml, with perhaps people actually dropping down and using Qt at some stages themselves.
Yeah, it just happened. So it's not like not entirely frowned upon that you go and write yourself a little widget that does something in Qt that we haven't exposed through Enaml. And to the extent we have a whole library of things that we've got do stuff like this. Things that we haven't contributed back to the project, but just silly widgets that we have a particular use case for, and the only easy way to get them done is to do them in Qt. And we just write them. The API inside isn't too bad. You end up with having to, it forces you to declare what the Enaml side should look like, almost a bit of an interface type declaration, which is why you can then use the testing backend and things like that. And then you just write your Qt widget there, and you can do whatever feels natural for Qt or WX or whatever you're doing your binding in, to do your like weird toggle button with colors or whatever it happens to be. And if you go all in, you can opt in for all the same stuff. You can opt in for support for style sheets. You can do everything that a normal Enaml widget would do. And then just plug that in when you start your application up and just say, I've got my extra repository of widgets over here. And it's like, yeah, no problem. If one of those come along, I'll bind them up for you. Yeah. So that's not too bad. It's a relatively good story there. Hey.
How complicated is it to have another renderer, say, make Enaml spit out JavaScript and HTML?
Yeah, I was waiting for this very question. So, because it had to happen. We have got a web renderer for it. The project, I have to admit, is kind of on pause. But we did get to the point where rendering an Enaml application on the web was possible. The reason we kind of paused it was twofold. We had more of a desire to end up with our developers writing some JavaScript and HTML, and we felt like that it's going to be easier story to hire there and everything else. So that's probably the first driver. The other one was that there are a lot of things in Enaml which are they're thinking like you're in a windowing toolkit on the Mac or Windows, not like you're in a browser. And we in the end decided that abstraction wasn't quite right for the web, and if we were going to develop a web application, we preferred to take all of our model code and all of the things that we have written already and just build a UI that makes sense for the web for those, rather than something that would render. But a bit like the story with Google Web Toolkit as well from back in the day, that ends up with a Java thing that outputs some JavaScript. It works, but you just end up hitting walls later on that we don't really want to be hitting. So that was the decision in the end. The project could come back to life. We may put it back up on GitHub, to be honest. It's just sitting somewhat stale on the side for now. But it's easy enough to do. There's nothing to stop you from having the toolkits. WX is one that we have quite a few applications in. For various reasons, they want to put things on the screen, and they're already written in WX, but they want to write their new thing in Enaml, so they can do that using the WX bindings, whereas the majority of applications use Qt. Hopefully that answered the question.
Great. Thank you very much. Let's thank Tom one more time.